Right, people, here's the last sketch on the principle of moments handout. And I'm going to, normally in a problem like this, the question would be find the support reactions and then also determine the sizes of the forces in all the members. But for now, I'm just going to work at the reactions at A and the reactions at B. Okay, right, at A here, we have a pin joint. And if you cast your mind back to the lesson we did on types of joints, a pin joint will have two possible reactions. So because we got loads acting down, I'm going to assume that that's going to go up. And because we have a force acting horizontally to the right, I'm going to assume that we're going to have a reaction acting horizontally to the right. Okay, and we have a roller joint, and because it's lying in this particular direction, there's no reaction this way horizontally because it's free to move, but I'm going to say therefore there's a reaction going vertically upward. Okay, and I'm going to give it their names. I'm going to call this VB, I'm going to call this VA. That wasn't too nice. And I'm going to call this HA. Okay. Now, people, you can call it what you want. Call it. Some people call it VBA, RABC, XYZ, whatever. You know, they confuse themselves. They confuse me. Just make it short, okay? So that you understand it. The vertical at B, the vertical at A, the horizontal at A. Short, okay? So less writing goes faster, and you won't confuse yourself, right? So we've put in the forces where we think the reactions are going to be, okay? Pin joint will have two possible reactions, and a roller joint will have one possible reaction. It can't be this way because it's free to move, but it can only be vertically because they can be restrained only this way. Right, next step is take moments about the pin joint first. Why? We take moments about the pin joint, so we eliminate those two unknowns and find that one. Okay, if we take moments about the roller joint first, often, not all the time, but very often, you find that you're going to have two unknowns in one equation and you can't solve it. Okay, so take moments about the pin joint, which will eliminate HA and VAY because the lever arms will be 0, making it 0, so we find VB. Okay, and then we can determine VA and HA, and it's job done. Right, so let's right, so I'm going to say the sum of the moments about A is equal to 0. Very important. In all the previous lessons, it was equal to something. Because why? The lever was turning. Whether it's a bar, a truss, a frame, a spanner, your arm, a wheelbarrow, it was turning. Here the frame is standing still. No? Equilibrium. Remember equilibrium on the previous pictures in this handout? It's going nowhere. So there's forces acting. Truss wants to turn, but the net effect, 0. Right? I'm taking moments about A. So there's 1, 2, 3, 4, 5 forces acting about A. You need to take all of them. Actually 6. There's actually 6, but that one has got no effect about A. Okay, so 1, 2, 3, 4, 5. Okay, there's 5 forces acting about A. You need to take all of them in any order, doesn't matter, but just take them all. I'm going to start with there. So it's, and about that point, it'll be plus. So it's plus 12 times. Now, all these are equilateral triangles, okay? So that means if I draw a line down like so, you should know this. If I draw a line like so, there's a right angle over there. The distance from there to there should be 2.5. Okay, 2.5. Right. So it's 2.5 plus 20 times. That is 7.5. 20 times 7.5. This one here. Minus. A lot of people don't see that. When it's horizontal, they just forget about it. Minus I'm going to do it on the side. Minus 9.24 times, what's that height there? It's not 5. Okay, so that height there is the same as that height here. So if I draw the line like so, can you see that? That height there is the same as that height there. Okay, do we know what it is? No, we don't. But we can do the famous old trigonometry. Right, so let's do it quickly. So I'm going to call it a little d. Oh, sorry, I didn't want that. Little d. So let me see. So the sine of the 60 degrees there, the sine of 60 is equal to small d over hypotenuse, which is 5. Okay, so therefore d is equal to 5 times sine 60. I'm going to work it out quickly. Okay, so it's 5 multiplied by sine 60 is equal to, I get 4.33 meters. You can either put it in here or work it out in your equation here. So it's 9.24 times 4.33. I must change this color here. Okay, is this plus or minus with respect to A? It is minus 10. And how far is this point from there? It is 15 meters away. 15 meters. Is that all? No, there's still a VB, and VB is minus with respect to A as minus VB times how far is VB? It's 10 meters away. And is that all? It's 1, 2, 3, 4, 5. 1, 2, 3, we go, is equal to 0. I've got one equation with one unknown, therefore I can solve for VB. Therefore VB is equal to, pick up a calculator, work at the answer and check my answer. Right, and what answer did you get? You waiting for me? Right, the answer is minus 1. Minus 1 kilonewton. And notice, people, notice. It's not kilonewton meters, it's a force. Okay, if you put kilonewton meters, I take a 1 mark for that. Okay, it's kilonewtons. If you leave the unit out, I take a mark for that too, because I'm feeling good and it's Christmas. Okay, right. And what does the minus sign mean? It means that this force here is actually going down. It's actually moving down. And let me change this here. Sorry, let me just, okay, right. It's actually going down. Okay, so the minus sign means that our assumption that VB is going upwards is not correct. It's actually going down, like so. Okay, here we go. Right. Are we done? No, we must still find HA and VA. Now, people, VA, we can either take moments about B to find VA. That will be the long proper way. Or, what else can we do? We can sum vertical forces to find VA. Okay, so I'm going to say the sum of the forces in the vertical is equal to 0. Okay, and how many verticals do we have acting? We've got 1, 2, 3, 4, 5. Right, so it's minus 12. Right, let's see. Okay, it's minus 12. That would be nice, will it? Minus 12, minus 20, plus 10, minus VB, which was 1, is minus 1, plus VA is equal to 0. And therefore, VA is equal to, let's see, VA, let's see, work it out and check me. Right, I got VA equal to plus 23 kilonewtons. Right, the answer is positive. What does it mean? It means that our assumption that VA is acting upwards is in fact correct. So it is 23 kilonewtons. Okay, so VA is 23 kilonewtons up and VB is 1 kilonewtons down. And to find HA, what do? We sum horizontal forces. So we're going to say the sum of the forces in the horizontal is equal to 0. We can actually look at it and see what it is, but I'm going to do the calculation. Okay, so plus HA, why is plus HA? Because we assume it's going to the right, minus 9.24 is equal to 0. Okay. So therefore, HA is equal to 9.24 kilonewtons. And because the answer is positive, because the answer is positive doesn't mean it's going to the right. No. Okay. Because it's positive, it means that our assumption that HA is in fact going to the right is in fact correct. So HA is equal to 9.24 kilonewtons. Okay. Now people, that's the reactions done. So whenever from this point onwards in your structures career, whenever you have to find the reactions for a frame or a beam, which we're coming to, that's what you do. Okay. Right. To recap quickly, you assume where you show where the reactions are going to be at the supports. If it's a pinch joint, there's two possible reactions. Why do I say possible? Because if this force wasn't acting here, HA would be 0. Okay, but because there's a horizontal force acting, there's a horizontal reaction. So a pinch joint will have two possible reactions. A roller joint will have one possible reaction. Next point in the step, take moments about the pinch joint to eliminate those two and find that one. Okay, then take moments about B to find VA, or some verticals to find the other vertical one, some horizontals to find the horizontal, and it's job done. Okay, so people, that's how you find the reactions of a frame. In the next lesson, which will be in the next folder, where we find the forces in all the members of the frame, that will be under a new lesson in forces in frameworks, and that will be in the next lesson. I will see you in the next lesson.